Okay, so we're talking about graphing quadratic functions, which are parabolas. And remember that the standard form of the equation is f of x equals a times x minus h quantity squared plus k, where hk is the vertex, x equals h is the axis of symmetry, and k is the max or min, the maximum or minimum of the function, depending on whether the parabola opens up or down. So anyway, we have an equation, f of x equals 3x squared plus 12x plus 5, and it is a quadratic function, and we want to graph it, but we have to put it into the standard form so we can figure out what the vertex is, and then we'll be able to graph it. So we're going to write it in vertex form, and to do that, we need to complete the square to make it look like a times x minus h quantity squared plus k. Now, your book does this one way. I'm going to do it an easier way. So please do it the way I'm showing you, because the way the book does it, I think, is a little bit confusing. So we're starting out with f of x equals 3x squared plus 12x plus 5. Now, we want to complete the square on the right side, but we can't do that because the coefficient of x squared is 3, and we need that to be 1. So what we're going to do is just divide both sides of the equation by 3. So f of x becomes f of x over 3. And then on the right side, you've got x squared plus, I left out the x here, sorry about that, x squared plus 4x plus 5 over 3. Okay, we're going to leave the left side completely alone, so don't mess with it, leave it like it is, leave that 3 in the denominator. And now we're going to try to write the right side as a square binomial plus something. Okay, so in our parentheses, we're going to have x squared plus 4x plus blank. And then outside the parentheses, we're going to have that 5/3. And whatever we add inside the parentheses, we're going to subtract over here. So we look at the 4, the x coefficient, we divide it by 2 and then square it. So 4 over 2 is 2, square it, you get 4. So we're going to add 4 and subtract 4. All right, so then we've got x plus 4x plus 4 is equal to x plus 2 quantity squared. And then we have 5/3 minus 4, so that's 5/3 minus 12/3, which is minus 7/3. And remember, all of this doesn't equal f of x, it equals f of x over 3. Okay, so now that we've completed the square, we did all the things we needed to do, we'll go ahead and multiply everything by 3 again. And that will leave us with, on the left side, it will just now be f of x. And then we multiply everything by 3 over here. We're going to put the 3 in front of x plus 2 quantity squared. And then we'll multiply the 7/3 by 3. And that will give us minus 7. So now we have our equation in the correct form. It looks just like the function there, a times x minus h quantity squared plus k. So we can see our vertex. Our vertex is going to be -2, -7. Okay, and it's -2 because in the standard form of the equation, it's minus h. So since this is plus, that means we have to take the opposite. So that'd be -2, -7 for the vertex. So there it is, right there, -2, -7. And then we know that this graph is going to open up because a, or the coefficient on the square binomial, is positive. So this is going to open up. So we know the vertex, let me write it down. I already said -2, -7, and then we have to find the x and y intercepts. So to find the y-intercept is pretty easy because you can just put in 0 for x. So f of 0 is equal to 0 plus 0 plus 5. So the y-intercept is 0, 5. So that is right there. And then the x-intercepts are going to be when this function equals 0. So 0 equals 3x squared plus 12x plus 5. So -12 plus or minus the square root of 144 minus 4ac all over 2a, which is 6. So that is going to be negative 2 plus or minus, and it's about 1.53. So negative 2 plus or minus 1.53. And so that gives us for our x, our two x-intercepts, that's going to be about negative 2 minus 1.53 is going to be negative 3.53. So the x-intercepts will be negative 4.70 and negative 3.530. And I should have said before that the y-intercept is going to be 0, 5. So these we'll just kind of estimate where they are. So now that we have those, we're going to go ahead and sketch the function. And now we want to know the axis of symmetry. The axis of symmetry is always x equals h. So in this problem, h, which is the x-coordinate of the vertex, is negative 2. So x equals negative 2 is our axis of symmetry. It's just the vertical line that goes right through the vertex. And then we want to determine the minimum or maximum value of f. And what we have here is a minimum value, and that is negative 7. So negative 7 is the minimum value of the function at the vertex. You can see it's at the bottom. And so the domain for this function is going to be all the real numbers because x can be anything. There's no restriction on x. So for the domain, it will just be negative infinity to infinity. Boy, that's sloppy. And then the range is going to be from negative 7 inclusive. Let me include negative 7 in our range because that's the lowest that y can go. So negative 7 to infinity for our range. Okay, the vertex formula. Another way to find the vertex of a parabola is to use the vertex formula, which is derived by completing the square for ax squared plus bx plus c. So the vertex is going to be negative b over 2a, f of negative b over 2a. So that's the vertex formula. X-intercepts and the discriminant. Given the quadratic function ax squared plus bx plus c, so anytime you have a parabola, you can use the discriminant of the equation ax squared plus bx plus c equals 0 to find the number of x-intercepts. Okay, because when the function equals 0, that is when you hit the x-axis. So remember, when you have the quadratic formula, you have negative b plus or minus the square root of b squared minus 4ac all over 2a. This number right here is called the discriminant. So where's that? Discriminant is that number right there. Okay, if you find out what that number is, you will know how many x-intercepts there are. If b squared minus 4ac is 0, the graph of y equals f of x has one x-intercept, right? Because that will disappear and you'll just have negative b over 2a, so you'll only have one value for that. If b squared minus 4ac is greater than 0, then you're going to have some value here under the square root. It'll be a real number, so you'll have negative b plus that and negative b minus that over 2a for your x-intercepts, and so that will be 2 x-intercepts. And then if b squared minus 4ac, the discriminant, is less than 0, that means that you have an imaginary number, and that means that there are no x-intercepts, so it has no x-intercept. Okay, so here's an application of parabolas and quadratic functions. So a stone is thrown from a 100-meter cliff at an initial speed of 20 meters per second at an angle of 30 degrees from the horizontal. The height of the stone can be modeled by h of t equals negative 4.9 t squared plus 10t plus 100, where h of t is the height in meters and t is the time in seconds after the stone is released. Okay, so this is a projectile motion problem. So we're going to use that to determine the information. So determine the time at which the stone will be at its maximum. Okay, so this function, the t is time and h of t is the height of the object. Okay, so we're trying to figure out when it will have its maximum height. So that's going to be at the vertex of the parabola. So we can find the vertex using negative b over 2a. So this is going to be our vertex. So the x-coordinate, the t, is our x because that's what we're putting into the function. So from the function, b is 10, so negative 10 over a, which is negative 4.9, 2 times negative 4.9. And so that's negative 10 over negative 9.8, which is about 1.02 seconds. So that is when it will reach its maximum height. And then h of negative b over 2a is going to be the maximum height because the function itself is the height of the stone. T is the time that it will get to that height. So we're going to take the 1.02 seconds and put it into the function h of t. So h of 1.02 going to be negative 4.9 times 1.02 squared plus 10 times 1.02 plus 100. And if we multiply all that out and round it to the nearest foot is what, or nearest meter, sorry, that's going to be about 105 meters at the maximum height of this object. And then C, determine the time at which the stone will hit the ground. Well, the stone, if you're up on this cliff and you're throwing it, it's going to go down. And when it hits the ground, that is going to be when its height is 0. So that is when the function equals 0 is when it's going to hit the ground. So that time is going to be, that's what we have to find out. So we're saying the function, when the function equals 0, that is when negative 4.9 t squared plus 10t plus 100, when that equals 0, that's when we hit the ground. So negative b, negative 10 plus or minus the square root of b squared minus 4ac all over 2a, so that's negative 9.8. So that is going to be about negative 10 plus or minus 45.39 over negative 9.8. So that is about 1.02 plus or minus 4.63. So if you have 1.02 plus 4.63, you're going to get about 5.65 seconds. And if you do 1.02 minus 4.63, you're going to get a negative value, and negative time is not a thing. So this would be about how long it will take the stone to hit the ground. Okay, a parking area is to be constructed adjacent to a road. The developer has purchased 340 feet of fencing. Determine dimensions for the parking lot that would maximize the area. Then find the maximum area. Okay, so we have to look at the situation, what's going on here. So you have these fences. You have X and Y and X. This is a rectangle. There's not going to be a fence next to the road. That's where people can pull in. So there are 340 feet of fencing. So our first equation that we can write is X plus Y plus X, or in other words, 2X plus Y is going to equal 340. That's all the fencing that we're using. And then we also, what we want to do is we want to maximize the area. So when it says to maximize the area, what we want to do is write a function for the area and then see where that function hits its maximum. In other words, the function will be a quadratic function, and we can figure out where the vertex is to figure out the maximum of that function, the maximum value of that function. So we're trying to figure out what X and Y need to be in order to have the maximum area for this parking lot. So first of all, we'll go ahead and use the equation we just wrote and get Y in terms of X. So Y equals negative 2X plus 340. Okay, that's not the function for the area. The area of this parking lot is X times Y. So this is the function that we want. X times Y, if we substitute this value for Y, we're going to get X times negative 2X plus 340, which is equal to negative 2X squared plus 340X. Okay, so this is our area function. We could call it A of X because it is a function in terms of X that represents the area of this parking lot. Now, we want to maximize the function, which means we want to find the vertex of this parabola. You can see that the parabola does open down and therefore have a maximum. So to find the vertex, we can do negative b over 2a and f of b over negative 2a. So so we'll plug in, this is our a and this is our b in this function. So negative b is negative 340 over 2a, that's negative 2 times 2, which is negative 4. And this is equal to 85. Now that is the x. So x has to be 85, and we can figure out what y is by plugging 85 back into the function, or we can just go back here and plug it in here. So that would be negative 2 times 85 plus 340, and that would be 340 minus 170, which is 170. So if x is 85 and y is 170, and this other x is 85, then these are the dimensions of the parking lot that would maximize the space. And we know that because the area of the parking lot can be written as a quadratic function, and a quadratic function where the coefficient on x squared is negative is a parabola that opens down, which means the vertex of the parabola is the maximum value of that function.